Hello, my name is Dr. Coca, and in this video, we're going to be looking at the second part of the extraction experiment. So, in the first video, we took a unknown that had 2/3 by mass of a neutral compound, and then 1/3 by mass of an impurity, either a carboxylic acid or an amine. We have placed that unknown in ether and in this separatory funnel. So now we're going to attempt to do an extraction. So I already have labeled 5 test tubes, 1 through 5, that we're going to be using throughout this experiment. So in your lab manual, you have the option of choosing either procedure 1 or procedure 2 for the extraction part. So one deals with using base in the beginning. The other one uses acid to try to remove the impurity. So since you don't know what the impurity is, whether it's acidic or basic, is sort of a guess at which procedure you should do. So we're going to do procedure 1, which starts off with by using 2 milliliters of 1 molar sodium hydroxide, which is a base. So I already have measured out 2 milliliters of 1 molar sodium hydroxide, and we're going to pour that into the separatory funnel. So we remove the stopper and we add it to the separatory funnel. So as you can see, there's 2 layers. So there's a clear layer at the bottom, there's a yellowish layer at the top. Depending on what unknown you have, you may not have necessarily the same colors. At the top, you might have perhaps no color. So it kind of depends on which compounds you're working with. So in this one, it just happens that one of the components for the unknown, either the neutral compound or the impurity, is a yellowish color, and therefore it's given some sort of yellow color to the organic layer. So at this point, we want to put our finger on the stopper, make sure it doesn't come off as we try to invert this separatory funnel to try to mix the contents. So one of the things I like to do, or at least the way I like to mix these 2 layers, is gently turn it upside down or sideways a few times, maybe 3 or 4 times, to get the 2 layers to mix really well. You don't really want to shake this really hard. In some cases, it might lead to emulsions. So if you want to prevent those, which are sometimes really difficult to get out, you might want to just gently shake them like this a few times. And in the process, you want to sort of, in the hood, you want to turn this upside down and release the stopcock, open or place it in the open position, and you can hear that sound of pressure coming out. So as you shake the contents of the separatory funnel, especially if you're working with a really volatile solvent like ether, it tends to build up a lot of pressure, and you want to release that pressure before well, usually what happens is the stopper pops off to release the pressure. So in order to avoid that and having your contents spill all over the bench, we want to release the pressure at some point as you're shaking it gently. So we let it sit in the vertical position for maybe a minute or so, and that's going to allow the 2 layers to separate a little bit better. So in the process of shaking it, even if you're doing it very gently, it does create or allow some of the layers to sort of mix a little bit. So we always want to give it a little bit of time to separate. Depending on what solvents you're working with, you might need to allow it to sort of separate a little bit more or less. So we're ready now to do the first extraction. We're going to remove the stopper, and we're going to take test tube 1 and place it underneath the separatory funnel. So I'll bring the camera a little bit lower, and you can open the stopcock and drain the lower layer. Now, you should know which of the 2 layers is the organic and which is the aqueous based on what organic solvent you're working with. So we're working with ether. If you look up the density of ether, it's less dense than water, so it should be the top layer. If you don't want to look it up, if you don't want to look up the densities, one trick is to either add more ether or more water, and whichever layer grows, that's the layer that is either the aqueous layer or the organic layer. So we're going to drain the lower layer, which in this case is the aqueous layer, into test tube 1. So as you get close, or as you start to bring the top layer down to the stopcock, you want to drain this really, really slowly so that you keep all of the organic layer in the separatory funnel, and you only remove the lower layer, the clear layer, which is the aqueous layer. Okay, so this procedure now is going to have us do extraction with sodium hydroxide a second time. So we're going to take about 2 milliliters of sodium hydroxide. We want to make sure we read our labels. So we want to make sure there's 1 molar sodium hydroxide. And we're going to use a transfer glass pipette, which has a pipette bulb on the top. Again, the way this works is you squeeze the bulb, release it, and when you release it in the water or whatever solution you're in, it picks up whatever solution is in there into the pipette. So we're going to transfer that to a graduated cylinder. It's just under 2 milliliters, so we're going to add a little bit more. And we're going to pour this 2 milliliters of sodium hydroxide into our separatory funnel. So the second extraction is going to ensure that anything that we did not take out in the first extraction is removed in the second. So the reason we're adding sodium hydroxide is to remove an impurity, the impurity in our unknown. So by doing multiple extractions, you can remove more of that impurity. So we're going to put our stopper back on, shake this gently, place it back on the ring stand. And you might notice that I forgot to release the pressure. That's okay if you're not shaking it too hard. Sometimes it won't be an issue, but try to generally remember to release the pressure, especially if you shake it really hard. While we're waiting for this to separate, I'm going to show you a ring clamp in case you have never seen one. So it has a screw part here. So if you place this through a ring stand, so generally is a long tube like this one back here. We can slide it down and then clamp on it with the screw. And then we can place a separatory funnel inside of it. Okay, so we allow this to sit here for about 30 seconds or so. That should be good enough. We're going to now remove the aqueous layer a second time. So we're going to open the stopcock again, drain that lower layer. As we get to the organic layer, we're going to slow it down and close the stopcock once again. So we have done the extraction twice now with base. That should remove any impurity, at least if it's the right type of impurity, by, again, doing this extraction multiple times. So the next part of the procedure involves acidifying test tube 1 and 2. So for that, we're going to take 6 molar HCl. So this is a little bit more concentrated than 1 molar, and that means we have to be a little bit more careful. Anytime you work with aqueous acids or aqueous bases, especially with higher concentrations like 6 molar and above, you want to be a little bit more careful. If you spill any on the bench, you want to clean it right away. Rub it down with a little bit of a wet paper towel, perhaps, to make sure that the next person doesn't accidentally touch it, and then it will start to sort of burn their skin after a few minutes of doing that. So we're going to take the 6 molar HCl, we're going to add a few drops to test tube 1. And so if we do this slowly, you'll notice sort of a little cloudiness in the test tube. And if we stir it up, it turns completely cloudy. If we take test tube 2 and we do the same thing, so almost a pipette full, so about 2 mLs, if we drop this slowly, drop wise, It is really hard to see perhaps on the video, but there's a little bit of precipitate, but nowhere near as much precipitate as test tube 1. Okay, so part of this experiment involves figuring out what the impurity is. So I won't tell you what the impurity is, but if you follow the reactions in the lab manual, you should be able to figure out based on the fact that we use sodium hydroxide in this particular unknown to remove the impurity. And then when we added an acid, HCl, we saw a precipitate form in test tube 1. That's a sign that the impurity was successfully removed with 1 molar sodium hydroxide extraction into test tube 1. So that, again, that tells us that we have successfully removed the impurity. And in the second test tube, we don't see much of an impurity or much of a precipitate. That tells us something as well. So that's something you should think about. What does it mean that if we're not seeing a precipitate in the second test tube in comparison to the first test tube? Okay, that pretty much tells us that we have successfully removed the impurity from an unknown. So at this point, we can move up to the drying procedure. If we had not seen any precipitate in test tube 1 or 2, we would have to do the second procedure, which involves using 1 molar HCl in the beginning to remove the impurity, and then adding 6 molar sodium hydroxide to see if we could get a precipitate. So either through procedure 2 or procedure 1, we should be able to see some sort of precipitate at the end of the procedure, which tells us we have removed the impurity. Since we saw it already, the precipitate in this procedure, we don't need to do that second procedure. And one last thing before we conclude with this video, I want to show you how to make sure that that you have added enough 6 molar HCl. So one of the common mistakes is for students, they don't add enough 6 molar HCl for procedure 1, and they don't see a precipitate, even though there should be a precipitate there. So the way to test for that is if you dip a spatula into test tube 1 after you added enough, if you think you added enough 6 molar HCl, and then touch a pH paper with that spatula, so wet it a little bit. You'll notice that so it's wet here at the end. There really isn't any color change. So this particular paper strip or pH paper comes in sort of a pinkish color. By adding a solution that is acidic, by the fact that we added enough 6 molar HCl, it doesn't change the color of our pH paper. If we had not added enough 6 molar HCl to our test tube 1, we would see sort of a bluish or purplish color on this pH paper. So I could show you that by taking just a drop from the 1 molar sodium hydroxide solution that is in the reagent bottle. If I touch the tip touch the tip of the pipette to this pH paper, you'll see there it turns blue. So that's a sign that whatever we're touching the pH paper with is basic, and that makes sense because 1 molar sodium hydroxide is basic. But if you have an acidic solution, it should stay sort of the same pinkish color. So at least that's the way it works for this particular type of pH paper. So this is called neutral litmus paper or pH paper, and that's sort of the way it works. There's other types of pH paper, so this one's a little bit more fancier. It comes with this color coding. So depending on the exact pH, so it's a little bit more exact. Depending on the exact pH, it'll give you sort of a slightly different color from a range of a very purple color to a very blue color.